BlueHat IL. How are you doing, BlueHat? Let's get some energy. Very excited to be here. Very excited to introduce my research on AWS this late August 2021. This is when I researched AWS. And the research is called Breaking Information from an Error Message to AWS Infrastructure. Now, I can't skip the classic Who Am I, right? This is the Cloud Edition. My name is Tzah Pahima, as you've heard. @Tzah Pahima is my Twitter account. You can follow me there for further research. I'm a security researcher at Orca Security. A little bit about my background. I was at IDF for 5 years at an intelligence unit. Then I had exactly 2 days off and went straight to Orca Security. No cloud experience whatsoever. I run a little bit on the side. I also freestyle rap, as you've heard. If you want to see a demonstration of that, that's off stage. I can show it afterwards, so come get me. Now, this research I'm going to talk about was taking place in the first 2 weeks I have in Orca. Really, not a lot of cloud experience that I had. The first thing we do need to talk about, though, is why am I doing what am I doing? Why am I researching the cloud? And why am I researching AWS specifically? What is my purpose? So, 2 purposes. One is my team purpose. I'm in the thought leadership team at Orca Security. Basically, we want to generate high-quality research and advance the cloud security in the world. And the second thing is my specific interest or my purpose, which is gaining more cloud expertise. Again, I had no experience whatsoever in the cloud. Maybe ran 1 or 2 AWS commands in my life. And researching the cloud is a great way to get to know the cloud. But why AWS specifically? So 2 reasons. One, it has the largest market share. 1/3 of the market is owned by AWS. So when you find a vulnerability or a finding in AWS, it's more relevant. It's more interesting. And the second thing is, and it's the most important thing, it's a challenge. There were not a lot of attacks on AWS infrastructure. So this might be the public first. OK. One thing we do need to get out of the way is this major buzzword called cloud. What is the cloud? So some of you may have ran a lot of commands in AWS, Azure, GCP, whatever. And some of you may have only heard the word cloud in articles. What does it mean? Let me introduce you to the world of the problem. Say, I want to set up a server, specifically a database. OK? Now, what do I need to do? I need to go to the hardware store, buy the hardware, plug it into the electricity, pay my electricity bill and everything. And then I need to install an operating system. I need to make sure I have backups. I need to make sure that I install the latest software and I don't have any vulnerabilities. But what happens if my database server suddenly is on fire, right? It's a problem. I need to make sure it's always online. I need to make sure it always has backups. And I need to make sure it's secure, encrypted, whatever I need. AWS, Azure, GCP, whomever, whatever vendor does this for you. And it's not only databases. It can be a file storage. It can be a web server, a virtual machine, whatever. You pay them. They do it for you. You don't need to take care of anything. And just so you understand how scalable this might be, Netflix, their entire infrastructure is on AWS. Everything you use, every server you communicate is on the cloud, no physical server that they're taking care of. Now, AWS, we need to talk about because this is the target of my research, so a short introduction would be this. AWS is an acronym for Amazon Web Services. It's the largest cloud provider to this date, and it has over 200 services. Just to name a few, and you choose which service you need to use for your purposes, right? So EC2 is a virtual machine service. Lambda is a service where you can deploy your own code. S3, you can store files. You have database solutions such as DynamoDB and RDS, and a lot of other services. CloudWatch, for example, can show you metrics. CloudFormation can help you deploy resources in your accounts. We'll talk about some of them later. But just understand, whatever you use the cloud for, you choose the services you're going to use. Now, aside from services, another keyword in AWS is regions. Basically, geographical regions. Each service, if I store files, for example, I want my file storage to be close to my customers, right? If I serve the East Coast, I'll choose a region near the East Coast. If I serve Israel, I choose a region that's near Israel. Basically, each region divides into availability zones. That's not so important, but they're data centers That's all there is to it. And because we're going to talk about the vulnerability in the cloud, we need to understand a little bit about cloud security. So 2 key concepts about cloud security. One is tenant isolation, and that's the important premise of the cloud. I'm a tenant, me and my organization. If your organization uses the cloud, you're also a different tenant. And even though we share the same resources, for example, we both have 2 virtual machines on the same physical machine, the cloud should promise that I can't access your virtual machine, you can't access mine. Same example, if I have, for example, S3 storage, we said it's a file storage. If I store my files on a hard drive and you store your files on the same physical hard drive, still I shouldn't access your files and you shouldn't access mine. That's tenant isolation. Different tenants can't access each other. And the second thing is a model that AWS relies on, which is the shared responsibility model. This means who's responsible for what side of security. If we take EC2, which is a virtual machine service, as we said, so everything that goes operating system and up is me. If I install unpatched software, if I don't make sure the permissions are correct, my fault. But anything below that, say the hardware, the networking, if there are hardware vulnerabilities, that's on AWS side. I can control it. So whatever I can control, my responsibility. Whatever AWS can control and I can't, their responsibility. Most researchers done on AWS are focusing on the upper side. What can the customer misconfigure unknowingly and is somehow not secure? Not a lot of people focus on this side. What can AWS do wrong? And this is what I wanted to focus on. Now, every good story has a villain, right? And we need to get to know our villain. The villain is a service called CloudFormation. So CloudFormation is 10 years old, actually turned 10 like a week ago, so happy birthday to CloudFormation. And it's an infrastructure as code service. We'll see what that means. But 2 key concepts or key words in CloudFormation are templates and stacks. It accepts a template as an input, and the output is a stack. That's all we need to know about the concept of CloudFormation. Now, 10 years old is pretty good for us because some of the code might be deprecated. You can target the code. It might be more prone to vulnerabilities. And also 10 years old is enough, or is old enough, to manage his own Twitter account. So at AWS CloudFormer, you can follow CloudFormation. Remember, it's evil. It's an evil service. So you can Twitter bully it, DM him, do whatever you need to know there. So we talked about stacks and templates. Stacks are the output. Templates are the input. What are stacks in CloudFormation? Just a collection of resources. Everything in AWS is a resource, a virtual machine, a file storage, whatever, everything is a resource. A stack is a collection of resources managed as a single unit. If you delete them, you delete them all. If you duplicate them, you duplicate them all. This is the way you do it. This can also be a part of a stack set. And what are templates? Remember, that's the input. Templates are just the recipe to how you make a stack. The types of the resources, their data. You can also have parameters, rules, conditions. For example, if you have a production environment, and a development environment, you might want to deploy different resources in each one. And the templates are either YAML or JSON, 2 formats. This one is a YAML template, has 2 resources. One is an EC2 instance. Remember, EC2, virtual machine. So this is a virtual machine. One of the data that is mentioned here is a shell script that initializes a web server. And the other resource is a security group, basically a firewall rule. And this firewall rule says, I allow any transportation in TCP, port 80, like an HTTP server should. Now, why should anyone research CloudFormation specifically? Why is it so interesting? 3 reasons. So first of all, it has plenty of features because you input a template, you can mention every resource you want. So there's a lot of play here. And it has a parser, actually 2, one JSON parser, one YAML parser for the templates, and they may contain sensitive customer data. We saw a template with shell script earlier. It might contain passwords, database passwords, whatever. That is super interesting, and it's a high-risk service. It does not only store files. It does not only operate virtual machines. It deploys resources to my account. So maybe I can give it a template, and it can deploy resources to your account. Could be very, very interesting. But it's nice to say that CloudFormation is a villain. You know, it was always bullying me. But that's not the case. Actually, me and CloudFormation, we used to get along pretty well. Actually, there was a time, remember, I have only 2 weeks of experience at this time with AWS. I didn't even really know CloudFormation. So how did I get to CloudFormation? I had a different research idea Not close. The research idea was bypassing logging in AWS. There are two services that are responsible for logging in AWS. One is CloudTrail and one is CloudWatch. And I wanted to make API calls in AWS. For example, try to download a file from you, try to upload a file to your storage, but not show up in the logs. That was my purpose. What are CloudTrail and CloudWatch? CloudTrail tracks user activity and API usage. And one thing we do need to remember is that everything in AWS, and I mean everything, is an API call. If you reboot your machine, that's an API call. If you give it credentials, that's an API call. If you create bucket, a bucket is a storage of files in S3, it's an API call. If you change its permissions, if you update a table in your database, whatever it is, it's an API call. Specifically, console login is an event, but everything else, and for our sake, everything is an API call. And when you create a CloudTrail logging group, you could say it's called a trail, and you choose what events to log. So in this case, I won't talk about the different types too much. Management events are events happening in my account. Data events are events happening to my data. If I have a file storage and you try to access it, it's a data event. If I change something in my account, it's a management event. Now, how does a log look? And remember, I'm trying to bypass it to make API calls without getting logged. How does a log look? It's simple. It's simply a JSON. 3 interesting points of data. One is who made a specific action. In this case, CloudTrail. The service itself made an action in my account. What did it do? Put the object in S3, meaning it uploaded a file to my storage. And how did it do it? Like the parameters, the circumstances. So in the request parameters, you can see the bucket name. Where did it upload the file to? Makes sense. How did I get from my research of bypassing the login mechanisms to CloudFormation? There was this feature introduced to me by Yoav Alon, my team leader and Orca CTO, and he said to me, Tzah, you're researching CloudTrail and CloudWatch and all these services. CloudTrail, we said, responsible for logging. CloudWatch shows logs and metrics, these kind of things. And he said, there's this feature AWS published. It's a new feature in CloudWatch. You have a lot of dashboards where you can see metrics, and there's a way to kind of program your own custom widgets. Might be interesting. I said, OK, let's click on the link. Let's get to the samples of this feature. And I went to sample widgets and literally clicked on the first one called Echo. It's a basic Echo word testing HTML. And it led me to this page. CloudFormation stacks, quick create stack, receives a template URL, a YAML file. Again, CloudFormation accepts templates. And if you press next, 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 you get to this page again, Echo where you input Echo, it gets Echo, Echo, Echo. Seems like it's working. But something was a bit off to me. And I was only, again, 2 weeks into AWS. But something did feel a bit off to me. It was this. There's this link, template URL. It's an HTTPS link to S3. It's not that weird because if you browse to this link, you'll get the YAML template, as you should. S3 is accessible by web. But usually when we're talking about S3 links in the API of AWS, you either give a bucket name in the API, or you give an S3 link. Not HTTPS as a scheme, but S3 as the scheme. And when I say usually, I mean usually you get S3 links, not HTTPS. Now, truth be told, this page that shows the actual feature that I set out to research is a page I've never seen in my entire life up to making this presentation. Because even though I set out to research this feature, the HTTPS link so much bothered me that I said, I have to focus on this thing. And why are HTTPS links so interesting, unlike S3 links? This one concept called SSRF. What are SSRFs? It's an acronym, server-side request forgery. Basically, if the server accepts a URL and it doesn't filter it, you can give the server a URL, and when it requests the resource from the URL, it might lead to localhost, or it might lead to the internal network, or to an attacker server. This is why HTTPS links are kind of dangerous. That's pretty good, but in the cloud, it's even more dangerous because you have a thing called IMDS. It's a server with a static IP 169.254 and so forth, which is used for VM configuration. So you can see the host name, the public IP address, all of this you have there. So you have interesting metadata about the VM. But also, you can give a VM credentials. Because my VM, for example, maybe wants to write to my storage in S3, so I can give it credentials to access my S3 bucket. Again, a bucket where you store files. So if you can access this and you can gain credentials, this can be super interesting. Some of you may have also heard about Capital One. An attacker added an SSRF there. They could have read the answer. They accessed the IMDS, got credentials, then leaked a lot of data revolving credit cards. Okay, so accessing data is interesting. If I can access the IMDS, would be very cool. But first, I need to understand where that template URL is coming from. So I looked at the URL, and I focused on it, and I got template URL equals whatever I put. And this is the page, right? So I said, okay, let's take this and put it in valid URL, just for the sake of it. Let's try. And I got this error. Template URL must be a supported URL. So it's not that easy. Now, where does this error come from? I turned on my Burpsuit proxy, and I got to this page. There's a request to CloudFormation service template summary, template URL, invalid URL, and you get an error. Template URL must be a supported URL. When you use it normally, you just get a JSON, which kind of summarizes that template. Makes sense, CloudFormation service template summary. Now remember, everything is an API call. Everything in AWS is an API call. Even this. So what API call is this? I just Googled CloudFormation service template summary. Enter. I got to this page, AWS documentation. Get template summary. It's CloudFormation API call, returns information about a new or existing template. And how do we know this is the API call I'm looking for? It has an argument called template URL, which says it's the location of file containing the template body located in an Amazon S3 bucket. This is documentation. So what I did right now, I said, okay, I'm trying to get the IMDS, right? I have maybe an SSRF. I don't know if I have an SSRF. I want to find an SSRF. Let's play with that template URL. We know we have this input, the normal input, the CloudWatch S3 Amazon AWS.com to that YAML file. That's the valid one. And when I put it as input, obviously I get the normal output. I get that summary of the JSON. So this one works. It bypasses that URL filter that we're handling with. Then I said, okay, let's try to change the scheme. Instead of HTTPS, try HTTP. Tried it. It worked. I said, okay, I can play here. But I said, okay, let's try sanity check to see if I can really influence the scheme. Let's try a scheme called blah blah. This one should fail, right? There's no such scheme called blah blah. It did work. So at this point, I was like, okay, I don't really understand what's happening. I think it's ignoring the scheme completely. Let's try to cut straight to the chase, go to the IMDS, and see if it works. Didn't work. Template URL must be a supported URL. Makes sense. It's not an Amazon S3 bucket. Remember documentation? It should be a file in an Amazon S3 bucket. So I say, let's try a different port. The same CloudWatch S3 Amazon AWS.com with a different port, 1337. Shouldn't work, right? This port is not open. This is not the HTTPS port. It did work. So it's ignoring the scheme. It's ignoring the port. It's probably only using the host name and the path. I said, let's try the @ symbol. Because the @ symbol, you might know it from SSH. You do user at a certain domain. It's how you give a username or credentials to your URL. So I said, let's try S3 Amazon AWS.com, like a valid S3 bucket, at evildomain.com. See what happens. Didn't work. So it can really parse the URL. It knows how to parse it. So at this point, I said, okay, I'm having a certain problem. I need to understand what it can do with the S3 buckets. I created my own bucket called BlueHat test bucket, and I told it, the template URL is BlueHat test bucket / existent. It's an existent file. It's empty. And I got a different error. Template format error, unsupported structure. Makes sense. It is a supported URL, so I don't get that error. Unsupported structure basically meaning because it's an empty file, it's not a YAML template. It's not a YAML template, does not contain any resources. CloudFormation can't do anything with it. Not interesting. And then I tried a non-existent file, just for the sake of it, and I got this, S3 error, access denied. this is kind of interesting because if you take that same URL and you browse to it with your browser, you also get access denied inside of an S3 error. Okay. Now, at this point, I said to myself, you know what? This starts to be a little bit harder than I imagined. I tried to play with the inputs a little bit more. Didn't really lead to nowhere but frustration. So I said, let's get back to my original research, bypassing the logging mechanisms. So I went back to CloudTrail. I only concluded that black box is hard, nothing makes sense, and I need to get back to CloudTrail. And I went to CloudTrail, and it logs API calls. And I saw this API call. It's a get object to S3 to that BlueHat test bucket / existent initiated by CloudFormation. Makes sense, right? I told the CloudFormation, access this, and it was logged. Seems like this is how it works. And then I searched for the other log. This is existent. Remember, I tried non-existent, and it gave me an error. I went to the logs, and instead of one log line, I found 2 log lines. One makes sense. It's CloudFormation, same thing, but non-existent. And the other one was this. Same get object, non-existent BlueHat test bucket, but an internal IP address, and the user agent was not CloudFormation. The user agent was Apache HTTP client / unavailable with a Java version. I was like, what is happening here? How does HTTP client know about my non-existent template that I led CloudFormation to? Doesn't really make sense. So I played with it more and tried to understand the behavior. Because again, this shouldn't happen. Only this log should occur, but both occur. So I understood it's a fallback. And Apache HTTP client is a client written by Apache in Java. Pretty basic. And the server-side logic that I understood goes like this. I go to CloudFormation, pass it a URL to my template. CloudFormation validates the URL, and after it validates it, it goes to the S3 bucket. When it fails because it's a non-existent file, then it goes to Apache HTTP client. Then Apache HTTP client tries to access that bucket. Now, if it works, cool. If it doesn't work, it spits out S3 error, access denied. Now, I searched HTTP client online, found a CVE, said, hooray, I can execute code on HTTP client. No, this vulnerability basically says to HTTP client, hey, parse this URL. You'll think you're going to BlueHat test bucket S3 Amazon AWS.com, a legit S3 bucket, but you'll actually go to Tzah's evildomain.com. Sounds perfect. Let's try if it works. I tried it. Wasn't working. Sad face. What else can HTTP clients do? What is my input? I only give it a URL. I tried the @ symbol, right? I tried a vulnerability with the @ symbol. Doesn't work. What else the URLs have? You know, the scheme, it doesn't use it. The port doesn't use it. We have URL parameters. And AWS has common parameters. One of them is XAMZ security token used to pass credentials to AWS services to authenticate yourself. You need to use 3 parameters, then you can authenticate yourself. And I said, let's try combining this parameter inside of the URL I passed to CloudFormation. So I did it. This is the request, the API call, BlueHat test bucket / non-existent, remember, because it only happens on non-existent. I get 2 logs, not 1. And I gave it XAMZ security token equals AAA, invalid input. Now, when I browse to that BlueHat test bucket with that parameter myself, I get access denied. No AWS access key was presented. When I use it in CloudFormation, I got that same thing. S3 error, no AWS access key was presented. There's some error parsing here. That's what I understood. Now, this was on a Thursday, and in Israel, most of you know, we don't work Friday and Saturday. Me specifically, I might not look the part, but I'm an observant Orthodox Jew. So basically, from Friday night to Saturday night, I don't write anything, I don't type anything, nothing. Shabbat Shalom. So all I could think of through the Shabbat was this error extraction. How does it happen? How does it extract errors from S3? What does HTTP client do? And I was about to take my nap after Saturday lunch. I get 1 hour nap, my beauty sleep, and I only could think of 3 things. One is HTTP client parses the error from S3. The other is URL parameters do work. It's an actual HTTP client. And this flow is only a fallback, right? /existent doesn't work. /non-existent, HTTP client accesses it. So parsing, parameters, fallback. Parsing, parameters, fallback. I was just about to go to sleep, and it hit me. When you start napping, but you then come up with a vulnerability, the problem was, again, it's Shabbat. I can't write anything. I can't type anything. I can't go to sleep because I'll forget it. So I just stayed awake, lost sleep, stared at the ceiling, and said, I need to remember this vulnerability. And I couldn't say anything to my family. Remember this about HTTP client. They'll be like, who? What are you talking about? Who's CloudFormation? Who are you playing with? Okay. So what was the idea? The idea was a race condition. How does the race apply here? AWS CloudFormation, normal flow with a URL, right? It validates the URL, goes to the S3 bucket, and fails. Now we should access Apache. Apache should access the bucket. But say right now, I upload the template to S3 before Apache HTTP client accesses it. And then Apache HTTP client accesses the bucket, and instead of finding a non-existent file, there is an existent file there. And what does this template, or what format will it be? It'll be the format of an S3 error, access denied. Now, two things can happen. Either S3 pass it to HTTP client, and HTTP client will say, okay, this is not a CloudFormation template, it's not a YAML or a JSON, you're fooling me. Unsupported structure, remember? Or it will say, my error. And I tried my own error document called this is literally my error. And if it spits it out, then this race works, right? There's something to look for here. There's more game. I said, let's implement it. Two things. One is burp intruder. Every half a second or so, goes to BlueHat test bucket, non-existent, through that API, get template summary. And the other thing is a shell script. What does it do? Instead of uploading an object, because this takes time and we want to win the race, so I uploaded the object called non-existent, even though it is existent now, and I set the permissions. I set it private, then half a second, then public. Private, public. This is the iteration. And I did it. I tried. This is the shell script saying private, public. When it iterates, this is the burp intruder. And this is how it went. Private, public, it iterates. The API keeps iterating. And I should have two responses. One is unsupported structure. When it's public, HTTP client reads it, says this is an XML. This is not a YAML or JSON. Unsupported structure. The other thing is when it is private and HTTP client reads it, what I should get is an access denied because it's private. HTTP client can't read it. These are the two errors I should receive if the race doesn't work. But if it does work, and it did work, S3 error, this is literally my error. This point, I was like, wow, this is literally working. I came up with something, I lost sleep over it, but it was worth it. Or was it? I mean, I only give it an input, and I can control the output a little bit, but what does HTTP client parse, right? It parses the S3 error response looking like this. And what format is that? Can someone tell me? It's an XML. And why are XML parsers so interesting? So there's this thing called XXC. Some of you may know it. Now, a normal XML document has a root element, has a children element, and can have attributes. Doesn't matter, we can have text. When this is rendered, it's just AAAA, right? The text inside of it. Now, there's a thing called XML entities. If, for example, I want to use lower than symbol or greater than symbol, they mean things in XML, so I need to encode them. How do I encode them? For example, ampersand LT, semicolon, LT lower than, I get the lower than symbol, A lower than B. Good. Now I can define my own XML entities. For example, if I want to use my name in an article or whatever, I can define the entity me called Tzah Pahima. If I want to be a rapper, I can define this entity called MC, containing obviously the most renowned world in the rap culture, which is Chika Chika. And then I can render this to be, hi, my name is Chika Chika Tzah Pahima. Nice. Why is this so interesting for a vulnerability? There's this thing called external entities. You can borrow a file for defining your own XML entity. So this is why it's called XML, external entity, XXE. In this case, nothing to see here, not malicious. It's an entity. I added the word system, And instead of this being a string, it's a URL. It goes to that URL, fetches the string, puts it in my XML document. Now, we know the HTTP client does parse XML. We know that some XML parsers are vulnerable to XXE. It's not always. You can configure it. I wanted to give it a shot. And I gave it a shot. And I ran burp intruder, right? Burp intruder with my script. And this is what I got. S3 error, roots, etc. You can understand. You can get the hang of it. And this is censored because there were a lot of users here. And when we searched them on LinkedIn and Google, they were AWS employees. So we had to censor it. At this point, I was filled with joy. I was jumping in my place. And I was like, this is amazing. But one thing I did not say, I need to say, I'm not racist. I mean, I love races, but they're not that practical, right? 25 to 30 requests for one leak, race conditions are not that practical. So I said, what can I do to maybe create one shot, one kill? One request, read a file. Not 28 requests, not 30 requests, not whatever. One request, one file. And long story short, you can do it. It's a feature called bucket policies. In S3, you can create and configure bucket policies to grant permissions to your Amazon S3 resources. Put this policy in your bucket, basically denying all access from people not having the words HTTP client in their user agent. Or rather, if we go the negative way, then only people with HTTP client in their user agent can access my bucket. And then what happens here is same flow. But instead of arrays, I start with contacting the S3 bucket. I give it my file called non-existent, looking like an S3 error payload with an XXE, and I give it a policy. The policy sort of puts a lock on the bucket. I access CloudFormation with URL. It accesses the bucket, fails. The bucket is locked, right? Then it accesses Apache HTTP client, which coincidentally has the key, unknowingly, right? Because it doesn't know about this concept, but his user agent contains HTTP client. The lock is removed. Everyone's happy. And in action, it looks something like this. I create a bucket. I upload the policy right to it. One request the API, and boom. Now, this is all good, but what can we really do? So we know we can read files. This is what we did right now. When you try to read a directory, I think I did it accidentally. You get directory listing. So this is good, thanks to Apache Xerces 2, which is the XML parser they're using in Java. So we have directory listing, we have file read, and we have an SSRF. Why? Remember, this is URL. Right now, it's URL to a file. But it can also be an HTTP or HTTPS URL. And why is that interesting in the cloud? Again, IMDS. We talked about it. Remember capital 1? Now, one thing I did not tell you about IMDS, there's this thing called IMDS v2. AWS saw the capital 1 incident, and they said, OK, you know what? Maybe something here is not very good. One SSRF can leak credentials, can do all that things. How can you prevent it? They created IMDS v2. Most SSRFs are just a GET request. One request, you get a response. Now they said IMDS, you can't just pull off a GET request. You need to make a PUT request with a certain header, then get the response, then, only then, you need to use that token and do a GET request. Basically, 99.9% of SRFs are unusable. And to enable this, or rather, it's always enabled to disable IMDS v1, because they're both enabled, you need to just click this, right? Disable IMDS v1, disabled. Obviously, AWS will do it because they have an article called I use IMDS v2, and they also strongly recommend adopting v2 and restricting access to v2 only for added security. Makes sense. I said, I can try this. Let's see what happens. Nothing to lose. This shouldn't work, shouldn't return any response because IMDS v2 should be enabled, but it does return a response. So, okay, AWS recommends IMDS v2. They are using it, but they're also using IMDS v1. Basically, doesn't do anything. Happy Hanukkah. Now, this is only data about the EC2 instance that we were using. We also found credentials, identifying that instance. You can enjoy the word code success because we had to censor it. And we took these credentials, used them to access my S3 bucket to see in the logs who accessed my S3 bucket. I did it. And it was AWS service invoked by AWS internal. Pretty good. Now, this is not CloudFormation, but still, an AWS service, it was kind of weird to us. We saw this and we were really excited and we wanted to explore further, but we stopped here because we need to have responsible disclosure. We disclosed to AWS, and props to them because in 25 hours they deployed the first patch, 25 hours since we sent our email, and it was fully patched in all of the regions in 6 days, so props to AWS. And if we want to talk about maybe further elevation, what we could have done with this, so again, I want to emphasize, these were not CloudFormation's credentials. They were identifying a machine as a part of the service of CloudFormation. And we didn't explore much further. What we did find were internal configuration files, evidence for internal services, internal credentials. Basically, this and Superglue, which is the research done by Yanir Tsarimi from my team at Orca, which is a service takeover. Highly recommend reading about that. We do believe that an escalation of this to an RC, if we would have continued, could have led, or rather would have led, to severe cross-tenant violation. Okay. We also validate the fix. I won't get much to it. We don't have much time, but you can find it in our technical blog. It's not tomorrow. Sorry. It'll be probably next week. And some takeaways, I'd say. So we have 3 takeaways, maybe a bonus one. One is black box is hard. I think you concluded that. A lot of speculating. You don't know what's happening behind the scenes. The other is logical vulnerabilities are a thing, right? Even though you don't have any source code, it's only you versus an API. You can still find logical vulnerabilities, which is pretty cool. And no platform is infallible, but I would say the cloud is more secure. Nowhere in the software world, for example, look at the log4j vulnerability, you can ever close it within 6 days in every instance. Here, one deploy, one patch, 6 days, everything's closed, everything's good. Now, we published this on Twitter. We had fighter jets in our logo, breaking formation, right, like a structure. And Twitter censored us. Basically, this is what we got for the first week or the first few days. Twitter doesn't like fighter jets. That's the next takeaway. Now, I promised I'd talk about research avenues in the cloud. So 2 things I'd say. One is services trust one another. CloudFormation didn't expect S3 to give it an XML external entity inside of the document, right? A malicious XML document. Doesn't make sense. So if you have communication between 2 services in the cloud generally, if you can trick one of them, this is probably more prone to vulnerabilities. Second thing is fallback mechanisms are a nice avenue. Again, HTTP client was only a fallback happening when it's non-existent. So I would say you can look at these things. And more researchers in the cloud would be much appreciated because I think more manpower generally researching the cloud, we can find even more exciting things. And good things are coming soon. Real nice vulnerabilities in other platforms even. I would say you can look forward to them. This is my Twitter account, @Pahima. Follow me for more information about the next vulnerabilities coming out. Was a pleasure to be here. Thank you so much, BlueHat IL.